So I'm here at the European Geosciences Union Conference 2025 in beautiful Vienna, beautiful day, with Zoe Roseby, a sedimentologist at the University of Exeter in the UK, who's a co-author on a very interesting paper that has just been published, I believe, in the Journal of Geophysical Research, or did I get that wrong?
Yeah.
That's correct. On the potential or the role that ancient mud deposits, and maybe some not as ancient on continental shelves particularly, play in the sequestration of carbon here on Earth, and why that's important in our quest to potentially stave off climate change or mitigate climate change. Can you tell me what's the takeaway from your paper?
So our new paper uses a new hydrodynamic model to find areas of mud accumulation on the Northwest European shelf. So the way that kind of muds are distributed on our continental shelves is primarily driven by hydrodynamics.
And the Northwest European shelf is what?
It's a shelf that's around the UK and Europe. So we particularly are looking at the area that includes the Irish and the UK economic zone. So we're looking at kind of three muddy depot centres, we call them, deposits of mud that exist in the Celtic Sea and in the North Sea. So this model, uses hydrodynamics to predict places of mud accumulation.
And hydrodynamics is really just how
kind of the movement of water, I suppose, in this case over the continental shelf. The reason that hydrodynamics are important is that this includes kind of considering how fast currents flow over the seabed. We call this bed shear stress. So,
it's called what again?
Bed shear stress.
Okay.
It's the
bed shear.
How much kind of shear stress is being put on the sediment from the overlying body of water. In areas where currents move very fast, we don't get deposition of fine sediments, but in areas that are very sheltered and have very low current velocities, we find that we can accumulate bodies of fine sediment, muds. So muds are important because they have greater capacity to store organic carbon than other substrate types or sediment types like sands and gravels.
How does it actually work? I mean, we hear this, but how does mud store carbon? Can you kind of give us a summary, overview of that?
Of course. So there's kind of two things that I would consider here. It's the fact that muds are very, very small. It means that they have a kind of a greater surface area per volume of sediment than sands and gravels. So it's the surface area to which carbon and organic matter can attach to the actual grain of sediment. The other thing is that muds have this capacity, or they have this tendency to form basins of sediments. They can actually form very, very thick deposits. So over quite short time scales, we can get thick accumulations of mud, which can then store quite large volumes of carbon. So it's a combination of the surface area of the muds, but also their tendency to form thick deposits makes them important for the storage of organic carbon.
And how would you define mud? Because people, they walk on the beach, that they have sand under their feet, that's wet sand.
Yeah.
How is wet sand different from your mud deposits?
Yeah.
And you have clay type mud, you have black
mud.
Black mud. What is mud really?
So mud is any sediment that's less than 63 microns is the kind of scientific cutoff between mud and sand. So sand is grains that are larger than 63 microns. So what you're seeing on the beach is all sand. In a kind of environment that we could see where you typically might find muds, we could think of mud flats, tidal mud flats, where we get this really organic, rich sediments. So they are very fine, and muds include silt and clays. They're a combination of both.
And the North Sea muds in the Fladen flat, is it?
The Fladen ground.
The Fladen ground, I'm sorry. The Fladen ground. What type of mud are you looking at there? What, if you had to characterize it?
So we see that we have quite silty muds, but we see a combination of it's kind of comprised of clays and silts. We really are mainly focused though on whether it's mud or not mud. So when we classify the grain sizes, we typically use a division between mud, sand and gravel. And we find that in the Fladen ground that the sediments are primarily muds, which makes it an interesting case study to think about carbon accumulation in muddy sediments in that kind of specific case study. And that's kind of a unique area, at least in the It's a unique area in the Northwest European Shelf in that the sediments that are there are very, very slow accumulating.
Mm-hmm.
So most of the muds that were kind of deposited to form the flading ground were actually delivered to that site during the deglaciation of the shelf following the last glacial maximum. So during the last ice age,
the last ice age.
yeah, there was ice covering the North Sea, and then as that ice melted, we got delivery of very fine sediments to the Fladen ground, this deep basin, from the retreating ice, and then also from river input. But as that kind of source disappeared, as those ice margins retreated, we actually see that sediment input to this site slows over time. So this means you have this muddy body of sediment that actually was formed quite a long time ago, and that's why it makes the Flading ground interesting, in terms of, for this study, is looking at how these different mud basins have formed and how that's been driven by the source of sediment as well as the hydrodynamics.
So how important do you think is the sequestration by these mud deposits actually is in the scheme of things on a global, if you just had to guess? And we know about old growth forests and how they can sequester carbon, even the ocean itself. But is there any idea about how the mud deposits stack up in the sequestration of carbon at this point, or is that still work that has to be done?
Yeah, I think a combination of those things. I think that it's being widely recognised now that continental shelf sediments are really important for storing organic carbon. They cover, vastly expansive areas, so we have this capacity to store carbon over, an enormous area. In terms of how important those muddy sediments are at storing carbon, we know that that kind of varies depending on location, depending on factors such as, primarily the input of organic carbon or organic matter to particular sites. So that might be from the overlying primary productivity of the surface waters, or it might be distance from land, because of course rivers will bring organic matter into continental shelf settings. So we're also starting to get an understanding of the key variables that drive variability in the amount of organic carbon that's being stored in sediments. So this is kind of a growing field, and people continue to work on these ideas to really refine this kind of relative importance of organic carbon in these sediments if we wanted to sort of form comparisons between those and terrestrial ecosystems that we might better understand.
Is there, this is just an idea that came to me. This may be crazy, but is there a way to make artificial mud that you could deposit on these coastal areas to actually sequester carbon?
I have to think. It's interesting because, I've been saying that, muds are really important for storing carbon, but in terms of it has to be in the right place, so where muds accumulate really depends on hydrodynamics. So those muds need to be in the right location.
Right.
And then they can't be disturbed. The process of actually removing muds, which actually might be doing a good job somewhere else, and then moving them into an ocean environment, by the time that process has happened, there's actually been quite a lot of disturbance. And we know that seafloor disturbance, such as from trawling, can have negative impacts on carbon stock. So I think that there's a lot to consider there, because you've got the...
But I mean, I was saying artificial, the creation of artificial sediments that could mimic mud in the same way that plasma mimics our, our natural blood, for instance.
I think it's so because you'd have to find a way of also not only making the grain size, mud size, but also how do you it's the combination of mud with the organic matter. The organic matter is stuck to the mud, so I don't know how you'd go about engineering that, but you would have to create something which is actually takes a natural system to produce, which is you've got erosion of rocks to create fine sediments, but then you've got organic matter that gets attached to the mud. So you've got two things going on here that you'd have to kind of consider.
Is it, at this point, do you have an idea of what type of mud is better at sequestering carbon on a long-term basis than other types?
Yes, so we are getting quite a good understanding of the key drivers of carbon storage in sediments. So I've mentioned already surface productivity. So in areas of the world where we get very, very large amounts of kind of phytoplankton blooms, those areas would be producing a lot of organic matter. Those plankton will settle through this, the ocean water column and settle on the sea floor. So that produces, or contributes to the sediment carbon stock. Also distance from land. There are a number of different variables, but we are already identifying where, which factors are most important, and then that actually would allow us to identify which areas are storing the most carbon, and how vulnerable that carbon would then be to disturbance.
And the name of the survey that is going to continue at least until the end of 2027. You're funded through the end of 2027. What is your name of the survey that you're involved in?
Okay, yes. So we work for the Convex Seascape Survey.
Convex Seascape Survey.
So we're funded by the Convex Insurance Group, but also we work really closely with the Blue Marine Foundation. So our project is a collaboration between Convex, Blue Marine Foundation, and the University of Exeter.
So thank you so much, Zoe, for taking the time to speak with me.
Yeah, thank you.
It's a fascinating subject, and I wish you all the best.
Thanks.